Welcome to the LemnaTec Academy. In this video, we will continue with our deeper look into LemnaExperiment. The recordings page is one of the central parts of LemnaExperiment. You see here all your recordings and images in a systematic presentation. Now, let's move to the recordings page. On this page, we have three major sections. The filter section at the top, the image tree on the left, and the image preview on the right. Currently we have no image selected, therefore we have no image to be previewed. Let's start with the image tree. In the image tree we have one top-level node for each experiment. In brackets to the experiment's name you find the number of snapshots and vessels included in this experiment. You may open an experiment with a little arrow in front of it. Inside each experiment's node, we have one node for each vessel. Again, you find the number of snapshots in the vessel in brackets. Inside each vessel, we have a list of snapshots. The snapshots might be underlined if they have been annotated, explicitly or automatically, and the snapshot name will be written in bold if there was at least one analysis executed on its data. If you open a snapshot, you will see a list of thumbnails. These are the thumbnails of the images recorded in this snapshot. They may differ in the cameras that have been used, in exposure and other camera parameters. Below each thumbnail you find the name of the camera used, the position, the camera label, the timestamp and the recording configuration used. If you click on a thumbnail, it will be opened in the preview section. You can change the space used by image tree and preview by pulling on the blue bar in the middle. You can also use the minimize button on the top right of each section . If you click on another thumbnail, this image will appear in the preview. If you control-click on another thumbnail, then the second thumbnail will be added to the preview. Let's focus on one image. On the top you find the zoom buttons. Zoom in, zoom to a specific zoom factor, zoom out, and zoom to fit the available space. Below the image you find more information on the current image, including the metadata and the annotations if the sample was annotated. There's also a slider to change the brightness of the image. This is particularly useful on grayscale images with high grayscale resolution, where primarily the lower values are used. This can be found on images taken with cameras like PAM or Hyperspectral. If you move the mouse button over the image while you press the Control key, you will see the pixel coordinates and the mouse pointer within the image and the color at the respective position. The color is given in RGB and HSV color space. Result images from analyses may show additional information. Let's get back to the image tree for a moment. You may have noticed the Save button besides the image thumbnails. With this button you can copy all images and data of a snapshot into a folder. This folder has the same name as the snapshot itself, but you can choose a parent folder for the snapshot folder. Effectively, you are exporting one snapshot to your disk. This will become important when we start to develop or modify analyses. The small menu button in front of the experiment and vessel names opens a menu. From this menu, you can select to copy the snapshots of the experiment or vessel which are currently opened, to copy the snapshots of the experiment or vessel which are currently selected, or to copy all snapshots of the experiment or vessel. Each snapshot will be saved in its own folder inside a folder of your choosing. The same menu is also available by right-clicking on the experiment name or vessel name. Below the image tree, we have a few buttons which you can use to start analyses on selected snapshots. We will cover this in the next video. Now let's have a look at the filter section at the top of this page. You can use this filter to determine which snapshots shall be displayed in the image. You can filter by experiment name, by recording configuration, by camera name, position and label, by the time frame of the recording, and the executed analysis. This includes the option to select snapshots which should not have been analyzed so far. If you filter by camera name, position or label, only snapshots and images which matches this filter are displayed. However, if you select Show all cameras, then all thumbnails of all recorded images are displayed. The filter will only select the snapshots shown, but not the images inside. This way, you may select snapshots which have a certain camera use, but show all images included in the snapshot. There are a few more things you can change in the filter section. You can change the layout of the image tree. The default is an experiment, then vessel, then snapshot tree. But you can select also experiment, then date, then snapshot, or experiment, then run, then snapshot. Remember, a run is a collection of snapshots that are taken in one instance by a single press of a button, so to speak. With laboratory systems such as the PhenoExpert Pro, a run contains usually only one snapshot. But with larger systems, e.g. conveyor systems like the PhenoExpert HT, they will contain many snapshots. The second option here is that you can select the size of the thumbnails in the image tree. Now let's have a look at a few special cameras and start with hyperspectral data. First, we have to find some snapshots with hyperspectral data. There we have one. The thumbnail of a hyperspectral data cube shows you a false color RGB image with 3 arbitrarily selected wavelengths. The preview has a few more controls than usual. First, if you move the mouse over the preview, you see the spectrum at the point of the mouse cursor. If you control press and move the mouse, you get the usual tooltip. On the right of the image, you can select the wavelengths. The bottommost value is the preview, but if you move up, you can select any wavelengths on the image. Please note, extracting the respective wavelengths from the hyperspectral cube may take a few moments. Since we split the light into many wavelengths during the recording of a hyperspectral data cube, the intensity at each wavelength is smaller than on an RGB or grayscale image. Therefore, you shall use the brightness slider to see actually the data. Please note the data shown here are the raw data. They are not processed by normalization using the white and dark reference. Let's continue with an example of a 3D data scan. The preview thumbnail of the 3D scan contains 4 rendered views from different sides: front, top, right, and a diagonal position. It takes a moment to open the 3D object in the preview. During the start process, the aforementioned preview image is displayed. In case of the 3D preview, the information of the 3D object is displayed on the right side. At the bottom, you find more technical information and a few controls. You can crop the preview, you can change the point size used to display the preview, and you can downsample the data. In addition, you have a couple of buttons to control the perspective. There is a default free rotating option, the view from the top, the bottom, the left, right, front, and back. In each case, you can switch between camera's perspective and parallel projection. Finally, we can center the 3D object. So, this is a recordings page. I hope you can now use it to check the images you recorded with Lemna Control and check this way the progress of your experiments. In the next video, I will show you how to execute an analysis on your snapshots, provided someone else has prepared the analysis definition with all its ingredients. See you there. Welcome to the LemnaTec Academy.